Okay. Okay, now let's solve some real problems. So a 100-kilogram car traveling with a speed of 25 meter per second skids to a stop. Pag nakita ka ng word na skid or skidding, ano yun, nagpepreno siya. The car experiences an 8,000 Newton force of friction. Determine the stopping distance of the car. So, okay, dito na tayo maglagay kasi dito na ibang given. 1,000 kilogram. Okay. So, at first, it's traveling at 25 meter per second. Nagpreno hanggang marating mo yung, makatigil na yung car. The frictional force between the tire and the road, that's it. And then, we're looking for the distance na na-cover ng car bago siya tuluyang makahinto. So, TMEI plus work done by the external force equals TME final. So, KEI plus PEI work done external force, KEF plus PEF. We can neglect the potential energy kasi nasa at zero height position yung car. And then, also, sige, para malinaw, 1/2. Pakita natin na zero talaga yung the final kinetic energy. 1/2 mv. Kasi hindi na magbabago yung mass, diba? Yung final velocity yung magbabago. But since it stopped, you were successful in stopping the car. Zero yung final velocity. That will result to a zero kinetic energy for the final position. So the car is 1,000 kilogram. It's speeding 25 meter per second. So square, don't forget that. 8,000 newtons. We're looking for the displacement and cosine 180. Actually, dapat wala na yung cosine 180. Kasi naglagay na tayo ng negative. Diba? Pag nalagay ka ng negative, that's actually the negative 1 doon sa cosine 180. Diba? Equals 0. Okay. Let me get a calculator. What should be the answer? Until it further. Okay, so this one will be 312,500 joules. 8,000 newtons. Actually, let's transpose it to the other side. Okay, divide both sides by 8,000 newtons. Remember, joules is Newton meter. So, matirang ka talaga dyan ng meter. Divide this by 1,000. 39.06 meters. That's the displacement. That's the skidding distance. Stopping distance of the car. Diba before, we would have used kinematic equation. But the work energy equation also does the same job. Okay. At the end of a shockwave roller coaster ride, the 6,000 kilogram train of cars, which includes the passenger, is slowed from the speed of 20 meter per second to 5 meter per second over a distance of 20 meters. Determine the braking force required to slow the train of cars by this amount. Okay, so before we were solving for the stopping distance, now pinapanap sa atin kung ilang braking force or parang frictional force yung kailangan para mapahinto yung car, or to slow it down to 5 meter per second kung ang distance allowance lang ay 20 meters. So TMEI equals TMEF. Again, yung train of cars ay nasa ground level na. So I forgot the work done by the external force. Work done by the external force equals KEF. So, hindi zero yung KEF natin kasi 5 meters pa siya, diba? Per second. 1/2 m initial velocity squared plus F, external force is friction, displacement cosine theta equals KE. 1/2 final velocity squared. Okay. Huwag na muna natin gawing negative, no? Kahit alam natin na negative work siya. You can do that kung 180, gusto mo lagyan na 180 yung iyong theta. Pero pwede din yung ginawa natin kanina. 6,000 kilogram, 20 meter per second squared plus, okay, we're looking for the braking force. Displacement is 20 meters. Cosine 180, that will be -1, equals 1/2. Of course, the mass doesn't change. 5 meter per second. Don't forget the square. Okay, now that's a lot. 1/2 times 6,000 times 20 square. That's equal to, okay, wow, 1.2. Is that a million joules? Plus, okay, gawin na natin negative. F fric 20 meters equals, okay, 75,000 joules. See the difference between the initial and the final? Kasi ano, diba, direct square relationship yung speed and the KE. Now, okay, so, okay, a little space now. Essentially what will happen is you have to transpose it, the 75 kg to the other side, and then this one to the other side. So, maging negative na siya, di ba? The difference between 1.2 k, okay, still very huge. Divide both sides by 20. That will cancel out the meters in the Newton meter. So you will be left with Newton, which is the unit of force. Okay, you should be getting 56,350 joules. Yun yung frictional force na kailangan. Okay? Okay. Now for the last sample problem, using the work energy equation. By the way, these problems ay involving external forces. They're the one doing the work. That means hindi conserve or nagbabago yung mechanical energy. In the next one, we will solve problems na conserve or constant yung iyong total mechanical energy. A shopping cart full of groceries is sitting at top of a 2-meter hill. The cart begins to roll until it hits a stump at the bottom of the hill. So that's the cart. It went down. This is the stump na sinasabi. Upon impact, 0.25 kilogram can of peaches flies horizontally. I think it's the yellow one. So upon impact dito sa parang hump, lumipad daw yung delata out of the shopping cart and hits a parked car with an average force of 500 newtons. Okay. So ang focus mo dito ay yung pitch actually, not the shopping cart. How deep a dent? Ibig sabihin, gano'ng kalaki yung yupe na ginawa niya on the car. Or you're actually asking for over what distance does the 500 Newton force act upon the can of peaches before bringing it to a stop. This is like the problem on the baseball glove na pinigilan niya yung baseball. So, the displacement of the ball is papunta doon. But, the gloves is giving it or applying force to it rightward. In the same way, yung can, if this is the edge of the car, the side of the car, it's getting displaced papunta doon sa left. And it's the car surface that will apply a force on the can para siya tumigil. So the focus here is the can. But although the given is about the shopping cart, like for example, gana siya kataas sa hill, nakalagay naman doon sa kanya yung can, diba? So that will also have the same value. So TMEI plus the work done by the external force, which this time is the applied force by virtue of the third law of motion. KE I plus PEI, work done by the external force, KEI plus PEI. Okay. Now, let's notice here na nag-zero yung initial and final velocity mo, no? Oh, I made a mistake again. Final. So that means we can cancel out the KE, the kinetic energies. Kasi there's no change during the initial and then the final. What's the formula for potential energy? mgh, height 1, di ba nasa taas siya nung una? And then mghf, which is nasa ground na siya. That means 0 na yung height, so that will also be 0. The mass of the can is 0.25 kilogram. G, acceleration due to gravity. Height is 2 meters. It was on top of a hill, 2 meter high. Sige, plus na. Work done by the external force, which is the applied force. Displacement. Okay, so actually, okay, sige na nga. Computin natin yung 0.25 times 9.8. 0.25 times 9.8 times 2, that's 4.9 joules. F of light is 500 newtons. As you see here, displacement, we're looking for that cosine, 180. So that will become negative actually. Okay. So 4.9 joules minus 500 newton times the displacement equals 0. If we transpose it there, it will become positive. Divide both sides by 500 newtons to get the displacement, which will be, okay, so okay, 0.98 meters, or 9.8 millimeters. Okay, that will be the dent na may iwan sa car. I will see you on the next video lecture when the mechanical energy is conserved. What will we do with our equation and how do we solve it?